Hey everybody, this is Opa. This is my final report for the class here, object-oriented programming. It's kind of late. It's almost midnight, so I'm a little groggy. But I want to get this done so we can take another class. Anyway, what I did was I put together a little report, kind of book report on expression problem. So what it is, though, is I put together I've been studying the closure language probably longer than I started studying Python and then I've been kind of studying programming for quite a while. Just enjoy it. Anyway, this is a little worksheet that's runs in the closure project file here. It's you can start a REPL enclosure. That's kind of what we're doing here. This is called a interactive REPL. It's a read, eval, print loop. Python, similar to Python's interactive shell, but this is actually running. Have Java, the virtual machine on this computer, and it's actually running on top of Java. So when you type in, it's not an interpreted language like Python is. It's compiled down to Java bytecode. Each little phrase that you put in here immediately compiles to Java bytecode and runs on the JVM. So it's something that's been around about 6 or 7 years, I guess now. In fact, it was used at a lot of the university level computer science courses before Python. Lisp was, which this is a newer version of a Lisp. Essentially, it's a Java library. A lot of it's written in Java actually, so you have access to Java. You've got it's a functional language, not a pure functional language, but it's a functionally based language. That's the REPL, and then if you do, this is the worksheet. It's called Gorilla. I don't know how I came up with Gorilla, but this guy wrote this application. This guy that wrote this application is like a scientist at some laboratory in England. He piddles with closure as a hobby, and he wrote this, I think, because he kind of come up with something similar to the IPython worksheet. But you type this line command. The line again is a build tool for closure, but it's going to run a REPL and then open up actually a web page that's we're going to be able to type commands into, similar to the IPython worksheet if you've ever seen that. So we'll open that link up. Excuse me. But the file I'm working on is let's see, load that up. Get it to work. It's final p.clj. Oops. Told you I'm a little tired. Try to get this done. Don't want to bore you to death here. I just want to show you what I did. Shrink this down. But it's running on the laptop, which allows you to actually enter code and evaluate it. Here's the code block here. I've already run this, so it's already been done. But if you do Control G N, you can enter code here just like we did earlier. That's just the REPL. This is a REPL too. So, but you can put text in it and markdown and links and stuff like that. So it's kind of cool. It's really good. You can kind of try code and it kind of records it. So if you hit on something that's working, you can kind of go on with it. And then if it doesn't work out, you can back up and make notes. And it's kind of similar, I think, to Mathematica and the worksheet, IPython worksheet. But anyway, the The book report I'm doing is going to be on this expression problem. So it's, I don't know if that link will even open up. I'm looking at it here, but it's this website actually was written by one of the developers of Clojure, but it was the first coined by somebody from Bell Labs, I think it said, was back in the late 90s. Said it was a new name for an old problem. Essentially, the expression problem is when you have two different code bases or two different libraries, two different systems, or two different modules that are written with different people, different times, just getting to where you can utilize them without any problem. Apparently there's a lot of problems in doing that. It's not as simple as it is in class that when we just did all our coding at one time and everything worked nicely together and it was just, our website was up and running and boom, we were done. But trying to take old code and new code and code written by somebody else, even if it's in the same language, even if it was in Python, is not easy. But anyway, these protocols are not new either. They're from the 70s, is what this article was saying. They're similar to a Java interface, which I believe is like an abstraction kind of over classes that you can kind of code against instead of going directly with the kind of accessing the classes directly. Not real clear on that, but anyway, these protocols have been around for a while. They've been in Clojure for a while. I think they've been around since version 1.2, and I think that's like 4 years ago. So anyway, this article kind of goes over some of the things that they've tried and not successfully happily with them, but this protocols is something they implemented into Clojure using some science from the 70s, which is basically what Clojure is science from the 70s. But it's essentially, if I can describe it just off the top of my head, but it's instead of a class, it's let me show you. I think I've got a link here. Nah, it won't work, will it? Because I'm in the live code. But if I go to where you can publish this, let me show you this here real quick. The links will work better under this. This is you're looking at the live worksheet, but this is going to be the published version of it, kind of the static version of it, and the links will work better on this. It's right here. No, that's not it. That's the source code for it. Just tired here. Let's go. Let's get this done here. I think it's this one right here. So this is actually a viewer that will load the same thing that we were looking at online. So basically, if you typed in that giant long address or went to my GitHub account, you could pull it up too. It's Dougie on GitHub. Welcome to look at it. Anyway, this is solving the expression problem makes it possible to extend pre-existing types like old code to new methods and functions, and vice versa, to extend pre-existing methods to new types or new classes. So that's essentially what you have to do to solve that problem. What he did is he kind of set up a grid that basically these were your classes down here in object-oriented programming, and across the top were your functions or your methods. And the only thing you could do without the protocols was to add new classes down here, and you weren't able to really work with this middle group here, these older classes and methods. And then in functional program, you could only add functions, and you couldn't really access these the way you wanted to. It's probably an oversimplified version of what the problem is, but he kind of laid it out as a chart initially, columns and rows to kind of show it. But what Clojure uses is called, it's a functional, isn't really object oriented, but it is written on top of Java, and so you have access to Java classes. So the developers of Clojure can kind of take the good parts of object oriented programming and kind of break it down into components that maintain the fields separately and the methods separately, and instead of glomming them together, which which is kind of how they describe a lot of class and OOP architecture. Is just kind of everything's kind of glommed together. But anyway, they use what's called a protocol, and you do that by creating a def record, which creates a Java, creates a map. I think it's called a map. And then this def type, it actually creates a Java class. I'll show you in the code down here. But this was a little tutorial on rock, paper, scissors, using some closure code to kind of show protocols. But essentially, this is doing a function that's creating a map of the what dominates in rock, paper, scissors, so that if you call the function dominates with the argument paper, it returns scissors, and then vice versa. If you call dominates scissors, what dominates scissors is rock. That's the old rock, paper, scissors. That's the logic behind that. But anyway, goes through here. I won't go through all this, but essentially you get down to where you're going to create the players, and they're going to use this def protocol. But this is the syntax for it. It's def protocol, and this is player. They capitalize it when it's a class like they do in Python, and then this is the signature. It doesn't really implement anything, but it just kind of shows you the form or the syntax for this particular player protocol. So if you type, after you evaluate that, if you type in type player, which kind of says what it kind of tells you what it is, it's a closure language persistent array map. So that's what it's actually created under the covers. A map is key value pairs. It's really good for structured data, which a lot of classes are. A lot of the classes we did in the Python class were very structured data that could have used a map. And then this def record is actually it is creating a Java class under the covers using this protocol, so they're actually able to kind of marry the two. I'm not sure exactly how that. This is you're writing all the code at the same time, but I believe this is how you could create a new class that would use. You could actually implement some methods from the old classes in it. I can't tell you exactly how that works, but this is the format that it uses. So they're creating different types of players using the player protocol. So that's how they would use it. But anyway, it's you can see if here's another one for a mean player. If you type in the type of that object, it is actually a Java Lang class. And then this is actually the game. I won't go into that, but basically it's very simple. That's what's nice about a lot of Lisps, are that it's a very simple syntax. There's not all the they call it ceremony in the code. It's very clean, very simple. It's real concise and clear, kind of what's going on. But anyway, that's kind of what I did. But this is the lab REPL. This is the where I got the code from. This is another. Stuart Hathaway is Holloway is one of the developers of Clojure. But this all this code is available on GitHub, where you can download it and fork it and clone it and play with it and look at the source code. It's really a great way. It's a great tool where you can actually see the different source code and how it's used and kind of make a little bit of sense out of it. But anyway, that's my silly project. Hope you liked it. Bye. See you next course.